Hello, today we are going to learn how to use the application KDAB GammaRay, which is a graphical user interface application which can connect to running Qt graphical user interface applications that use either Qt widgets or Qt QML. And you can both read from the application that GammaRay is attached to, so you can see its structure, what icons, what events, what happens inside of the application, but you can also write to the application, so you can change, for instance, the value of properties, colors, texts, etc. with some limitations. So let's look at a application. This is the application calc with 2 Ks from the KDE community, uses QML. We have started the application KDAB GammaRay. And here we can see the important limitation of the application KDAB GammaRay. All of these processes, such as this one, /usr/bin console, uses a different version of Qt than KDAB GammaRay. So we have the limitation that both KDAB GammaRay and the application that we want to connect to should be compiled with the same Qt. So the same Qt major minor version, the same Qt architecture, the same Qt operating system, the same compiler, everything. Okay. So in this case, we have built using kdesrc-build, KDAB GammaRay, and calc. And we're using a Qt 6.7 built using kdesrc-build, whereas this /usr/bin/console comes from the official deb packages from my Linux operating system, which is Ubuntu 24.04, which uses Qt 5, not Qt 6, so Qt 5.15. So using KDAB GammaRay, I cannot connect to any of the processes from /usr. I can only connect to those from ~/kd/usr. Okay. The only possibility is already pre-selected, so I'm going to just click on the button attach. Okay. We can see that the title bar of the application that KDAB GammaRay connects to has changed title text. So previously it was calc and then minus calculator, and now it says injected by GammaRay within parentheses. And also the title bar icon now has a blue outline. Okay, so this application is made to be convergent, to run on Android, on KDE Plasma mobile, so on mobile phones, but also on desktop computers. Let's see what KDAB GammaRay offers. First of all, it offers top-level tabs. So these ones, events, font browser, locales, etc. Now, this KDAB GammaRay application, in my opinion, has 2 entry points. For Qt widgets-based apps, it's the top-level tab widgets, this guy. Seems that the application calc doesn't have such a thing, so maybe it doesn't depend at all on Qt widgets. And the other main entry point is the top-level tab in GammaRay, Quick Scenes. So Quick Scenes is for QML Qt Quick applications. Okay, so let's see first of all what it did if we just clicked on the Quick Scenes top-level tab. It provided a combo box with windows and QML items, top-level items that we can connect to. So Qt Quick root item. There's just one. So let's see a bit how this application works. Calc with 2 Ks. So KDAB GammaRay might crash but again, it's a very powerful application. It's probably the only application that does what it does. So seeing the live state of all of the QML items, being able to edit some of the properties. So KDAB GammaRay is processing a ton of information at the same time, such as all of the incoming graphical user interface events. It might crash, you just restart it, that's it. It's a limitation that you'll have to work with. Okay, I have reattached. So this is a desktop calculator application similar to a hardware calculator that you would use for maths. So you can do things like square root of 12321, which should be a nice number, equals. How do we do that? Square root 12321. Okay. So you put the square root first and then the number. Okay, so it has some advanced buttons, such as the sine, cosine, etc. functions. Okay, let's see how the P number looks like. How do we find out? There's the clear button, this C. Okay, PI. We can see live whatever happens in the application in that GammaRay is connected to. We can see it live in here in this tool window. The default zoom level is 100, but that's too much for me. I want to see the entire application by default, which is 50%. And now let's dig deeper. In this tool window, we have all of the items. In Qt fashion, items have parents. So there's a tree view of QML Qt Quick items. They start from this type Qt Quick root item. There's just one top level item, and then there's children of it. Okay. This button, pick element in this tool window, allows us to select one QML item. For instance, we want the QML item with the text for the button 9. Okay, let's zoom a bit. How can we zoom 75%? Not sure. Okay, so I have selected the letter 9 because I guess that this is a text that maybe sits on a button. Let's select the button. Okay, so this button is actually a Qt Quick rectangle. So this is the QML item of type rectangle. This is one of the top 10 most standard QML types from the Qt framework. And it's themed in a way such that it has a rounded rect border. Okay, let's see again the text. So the content of the text of the text should be 9. Let's see first what this thing is. So it's a label. Let's see if navigating to the source code actually works. So we go right click on the object in the object review and we go to creation. Okay. So it says that there's a thing which is number button.qml, which is a QML file. And this is placed inside of the resources of the application calc. Okay, back to where we were. Right click and go to creation. So number button.qml is the name of the file. So that will be a QML type that you define. So QML by convention, the name of the file .qml is going to be the name of a QML type, a custom type that you define in that QML file. Okay, so there's a number button QML type. Let's see everything a bit wider. So there's a small box shadow, a background fill, and a label. And a icon that's only visible for the clear, edit clear icon. Let's see that. So the clear button, this one, does not have text. Instead, it has an icon. We can see it in here. It says Kirigami icon. So this is a QML type from the KDE community, from the KDE framework version 6 library named Kirigami. In the case that it should display this icon, which it does, then this expression is bound to the property visible, so the icon becomes visible. And because this is what should be displayed in the button, for instance, for the button 8, the text 8 should be displayed, so that's different from this edit clear icon. So then a label should be displayed. So on the buttons, you can either have text or one icon. All of the buttons have text except for this button, which only has an icon. Okay, so the font weight is bold. Let's see what we can edit on this application. So we can write to the calc application. Go quick scenes. So we've selected the text of the label. Let's see if we can edit the text. So this thing make it something different. 19. Yes, so some of the properties that are Qt properties that exist inside of the running application can be edited at runtime. So the Qt metaobject, introspection, machinery allows you to both inspect the application and see the value of the properties, but in some cases you can also write to those properties. You can also list all of the properties that are available inside of a running Qt application. Okay, let's see what else we can do. Do we have a color? It's black. Let's see if we can change this. Make it red. And we can do that. Some properties expose a more complex type, not just a QColor or a QString. And those, so I know, resemble for instance, a C++ struct. So that's harder to actually edit from KDAB GammaRay. Okay. What else can we do in here? We can see all sorts of in-depth information about this type. So we know the QML type. This probably comes because label is defined in a .qml file, not in C++. Lowercase label, that's the ID of this thing. So the tag ID let's copy this part. Back to quick scenes. Okay, so lowercase label is this string. We can see it uses the correct icon, so in uppercase T, which means that probably the Qt Quick type is defined from the Qt framework, and it's a basic QML type. Okay. Very important is for us to understand the parents of a control. So when we're inspecting this label, we actually want to know its parents. So we guessed that the button has inside a label, but we did not know anything. We did not guess that there was an intermediate between the parent and the child. This QQuick item with just a C++ address. Okay, so that's probably the content item, type item. Okay, so it selects line 88. It doesn't scroll to line 88, but it makes the background of the line bluish. Let's do the same thing for the label. And again, it changes the background of the line where the label is actually used, where it's created. So on line 91. Okay, so after you go to creation, you need to scroll until you find the line that's with this blue background, and also there's this vertical bar here. Okay, so let's see, what was that? Or KD Kirigami primitives icon. And it's grayed out. Let's see why it's grayed out. It says item is invisible, so I'm just hovering with the mouse on top of this row. Says that the item is invisible, and it has 2 children. And it has the parent that we expect, which is this content item. Okay, can we make this thing visible? I know. Can we make this thing not visible? Okay, so the label is no longer visible. Let's see that it became grayed out. So it did, the line label. The Kirigami icon is also not visible. It's grayed out. Let's make it visible. And it only can display one icon, which is this one, where it says icon source, edit clear. Whatever, source, edit clear. And the type is a Kirigami icon. So the source is a Q variant. Maybe we can edit it also. Let me see how we can change this icon. So I have an installation of kdesrc-build. This is the KD Git repository Breeze icons. This icon comes from Breeze icons, probably. So let's search for it and its siblings. Okay, so there's edit clear, and there's, let's go there. There's also edit bomb. Let's see this one. And it did work. Now we have the bomb icon instead of the 9 text. Okay, don't expect that you can edit all of the properties, but some you can. We already saw booleans for visible, we saw Q variant for source, we saw Q string for text. Okay, what else can we do? We can measure pixel sizes, but for measuring pixel sizes, I recommend the KDE application key ruler. And we have the option of not needing to click on the calc application, but we can click on this tool window. So let's go 50%. And this redirect input says in this mode, all mouse input is redirected to the application that we're connected to. Okay, so for instance, we can press the C button. Not really. We did press it, but nothing happens. Okay. We can actually press the buttons, but the events behind them do not happen, and the clearing of the previous button does not happen, like this. Okay. Not a problem. Maybe For QML applications, this functionality is not that well supported, redirecting events. Or maybe there's a bug in the application calc. Okay, inspect colors. Very important when you're doing QML applications is to see which QML items are only partially viewable or are outside of the view. So even if the QML item has the property visible true, its X and Y is way out of the X11 application window. This thing, it says the item is visible but out of view. And it's also zero size. For these types of warnings, it shows in the tree view with QML items this warning icon. If you hover on top of it, you have two warnings at the same time. So it says that width and height is 0 and visible is true, but it's out of the view. Let's actually see what happens there. So visible true, X and Y 450. So this thing may be the Y coordinate, which is this thing, is out of the height of the calculator. And then the size is 0. So that's width and height is 0. Width is 300. And height is 0. So yeah, so if any of the width or height is 0, then yes, the content of the QML item will be zero size. Item has inactive focus also shows an additional icon in the tree view. In this case, is this page row. So this is the KDE Framework 6 Kirigami page row QML. And in there's a global toolbar UI. This thing. So it's a Qt quick loader. Which is the way of lazily loading QML source code. And this is the source code that's going to be lazily loaded when needed. This makes QML applications load faster, take less RAM by default, less memory. Okay, some of the QML files which are part of the resources will open in the built-in text viewer under the GammaRay main tab resources. The QML files that are not resources inside of the Calc application are shown using Qt Creator, which we can change from here. We can say, please open in Qt. So in the KDAB GammaRay main menu, settings, code navigation, and then Qt. Let's do that. So this loader thing. Okay, so we navigated to the correct line, 934. So there are sometimes styling issues, sometimes the size of the fonts is wrong, the family of the fonts is wrong, the color scheme is wrong, like you have black on black text. All of these things can be inspected in depth using KDAB GammaRay, and you can actually see what's happening there, not just go by gut feeling. So you can actually put your finger on when in the tree of QML items the issue starts happening and why. And then, for instance, if you find a bug in here in some property, you can edit that property live using KDAB GammaRay, see that the bug has been fixed correctly in the running application, and then you can do a code change that acts on this QML item to change, in some cases, the value of a property to what you put in KDAB GammaRay. Okay, so that was how to inspect QML applications. There's all sorts of advanced information that you can have about the application. This is the bread and butter. So this preview tool window and this items tool window. In here we can read and write properties. There's the list of methods. There's the list of QML connections with slots and signals. On the bottom you have the signals. No, on the bottom you have outbound connections, and on the top inbound connections. So that's a connection is a tuple with 4 items. There's the receiver signal and the slot sender, whatever. Okay, bindings, that's about QML bindings. You can see them. You can inspect the source code. So colon in QML might mean QML binding, but might also mean a JavaScript part, a JavaScript block. Or just a hard-coded literal value. Okay, then using the Qt metaobject protocol inside of a running Qt application, you have exposed a number of reflection information, such as Qt style enums, signals and slots, which are not connected, which are connected, properties with all of their machinery, getter, setter, and on change, observer, what else? Qt classes, Okay, let's see the GammaRay main tab problems. What does it do? So it says that for Q objects with bindings, it will try to find the binding loops. Binding loops are most common for QML applications. The list of Qt Quick items that are visible but out of the view, which we could see previously in the Quick Scenes tab. If you're expanding the entire tree, and that's, I'm not sure what the button is to expand the entire tree, and then you need to navigate through all of the QML items and see which one has this additional icon for warning. Okay, so QML type for button. This thing, number button, abstract button. There are some buttons which are not visible because they're hidden on a second page and become visible now. This is when the size of the window is too small. So because the application can adapt its layout depending on the size of the window, it will have a different layout on mobile phones, on a different layout on tablets. When we resize the application, at some point there's a breakpoint. From there, all of the buttons become visible. Okay, this is the breakpoint. Okay. What else? All of the buttons have inside of them a label. There are some buttons which are not visible but are not part of the, I don't know, the panel with many buttons, but are part of the main menu. Okay, so the paste button becomes visible after a while. Before that, it's hidden under a 3 dots more actions button. And the same for the cut button. And for the redo button. And for the undo button. And for the history button. Okay, so buttons which cannot be visible by default, there's not enough space to show them on the main toolbar, should probably become icon only first and then get hidden. But that's the current policy of the application. All of the buttons in the main toolbar are always icon plus text on the right of the icon. And when there's not enough space, the buttons will, from the right to left, the buttons will move to the more actions menu. Okay, what else do we have here? What is this? Row layout in the toolbar. Okay. Other type of issues except zero size and visible but out of view. Qt signals which are outside of the source code of the application. So QSRHI. Okay. else do we have here? We have the list of all of the Qt objects, so all of the C++ and QML objects that have Qt meta object information about them. Network interface cards, probably network traffic, if you're using the Qt library for doing TCP, UDP traffic. Okay, then we have QML models. There's a list model. Meta types. So this is the list of types that can be introspected, can be reflected upon using Qt meta object protocol. So all of the types that start with Q and the Qt QML types. This is the total of Qt introspectable types. You can see what type of Qt types has the most objects in this application. I would expect QString to be the most often used type. Sorting is not that great because it continues to keep the tree view structure. Let's see what these messages are. Q warning. So Q warning, QC debug, Q debug, etc. That's the debug logging framework that's built into the Qt framework. Similar to, I know, log4j, log4cxx. Okay, so this log line, Q meta object index of signal has been written to the debug log. Right now, it doesn't really say microseconds, which it should say. At least milliseconds should be displayed here. It doesn't say that it's a warning. Okay. In here, you can configure the Qt logs, debug log lines that will be displayed or not, depending on their category, and the log level, if it's warning or debug. That's, for instance, the fonts that are available to the application. Okay, so all of the events that have been erased with time with milliseconds. I'm not sure who can read these huge list of events, but maybe if you use filtering. Okay. What are these? Q shortcut, Q font database. Timers in most graphical user interface toolkits and frameworks. There's a timer class built in. So there's such a thing in C#, in Qt, in Delphi, etc. This usually has one property, a duration, and then at the end of the duration will invoke an event, a method. And if it's repeating or not, and if it's enabled or not. Okay, debugging information about the Qt installation. Environment variables. And theming. Icons available, color palette. Okay. So this is showing real time Qt style events, signal slots, connections, how they happen. And there's a huge ton of them. This is an easy way to crash the applications by going to the signals tab without any need. So if you really have a use for going to this tab, do go and maybe immediately use the search functionality. Otherwise, you risk the application crashing because of such a massive amount of information that's happening here. Okay, these are Qt style resources that are embedded inside of the executable, inside of the KALK file. Now let's look at a that was a Qt QML application. Let's look at a Qt widgets application. Similarly named KCalc with just one K. It's a desktop application using Qt widgets, not Qt Quick. We'll connect using GammaRay to it. Again, we cannot connect to any other application, just this one. Uses the exact same version of Qt as GammaRay. It's selected by default. We go attach. Okay, the entry point should be the widgets tab. You should look at the object tree. Before looking at the object tree, you should actually select the correct window. So let's see how many windows does this application have. So there's one, there's two, there's three, there's four, there's five, who knows how many. Okay, so that's about it. Let's see how we select this window. We'll make it go away. How do we do that? Okay, and we can look in the tree view if a new window will appear in this list in the treeview. So find action. So this K command bar. And now it has disappeared. Okay, so this K command bar appears every time I open help find action Control A Alt I. So I guess this one is it. It keeps disappearing once you touch it. So let's look at another window. For instance, this window. Where is it? Let's look at the settings window. Okay, where is the settings? This guy. Let's zoom to 50% back. So this is the main window, K calculator. And it has a child Qt window, which is this settings, kconfig dialog. We can do similar things to what we did in QML, such as we can pick the constants button. Cannot do that because it's actually using actions probably. Let's select the OK button then. Okay, so this is a standard Qt widget, which is named Q push button. Let's see if we can edit some of its Qt properties. Is there a visible? Yes. Let's move the X a bit to the right. We cannot. Let's see if we can change its icon. At letter I. This thing is of type Q icon. We cannot edit this property. Again, this is kind of like a struct. And I'm not sure that we can edit it. In order to actually edit, we would want to get at the name of the icon and change that. Okay. What else can we edit? Nothing. Height is not editable. What about the text? Yeah. Some properties we can edit, some of them we cannot. We should be glad that we can edit some. That's how it is. Okay, so the same list of Qt style methods. Qt style signal slots, connections, inbound, outbound connections, receiver, sender. There's Qt style painting. I'm not sure what this thing is. So this is the stack trace to the what? Triggered, activated, mouse release event. Not sure what this thing is showing. Okay, so again, the entry point for Qt widgets, graphical user interface applications once you connect to them using KDAB GammaRay is inside KDAB GammaRay, the main tab widgets. You have all of the Qt windows available in this main treeview. You can search just for buttons, if that works. It doesn't search for substrings. Okay. Q push button. I don't know how search works. Okay, calc button. Okay, calc button. Maybe it doesn't search by type, just by object name. Who knows? Let's see, division. Nope. Substring, no. I don't know what search does. Okay. You'll almost never probably need Web Inspector, Wayland Compositor, translations, timers, text documents, system, styles, signals, network, models, MIME types, locales, font browser, actions. But you will probably need widgets and its associated tabs. So once you select a button, you have this option to go to other top-level GammaRay tabs. So you can go to the Objects tab. You can go to the metaobjects tab. And you can go to the Signals tab. The Qt controls that are not visible, so have visible false, are shown grayed out in the treeview. Let's see if redirecting events works. We'll select the top level window, have them side by side, redirect input, and now we're going to do what? To perform an addition. 1, 2, 3 plus 1, 2, 3 equals 2, 4, 6. So in this case, for Qt widgets applications, the redirect input tool in KDAB GammaRay seems to work okay, as expected. Okay. Again, we can see in the application that KDAB GammaRay connects to, that the title bar has been changed, and it says injected by GammaRay in parentheses. Okay. So that's about it, how you use KDAB GammaRay. There's this analyze painting thing. And there's also that 3D view of painting, if I remember correctly. So KDAB GammaRay is also useful for determining painting issues. So, why a button is not doesn't have the size that you would expect. Why? Because there's a control on top that has smaller size and does trim the control that's a child of it. Or I know half of a label has background red and the other half is background gray. Why? Because on top there's a transparent, translucent item that's not even a parent of that control, but it's just placed there in with a superior Z order. It's hidden somewhere in here, that information. I'm not sure how to actually detect painting issues and see the painting tool in KDAB GammaRay. Okay, let's now look at more information about KDAB GammaRay. So this is the KDAB GammaRay GitHub repository, github.com/kdab/gammaray. It's an actively developed application. In my opinion, KDAB GammaRay should be part of the Qt framework's binary releases and source code releases, so part of the tarballs. When you're using the Qt online installer listing, it should offer to install binary versions of KDAB GammaRay for that specific Qt version. So for instance, if I'm installing Qt 680 snapshot from dev, somewhere in here should be available the correct KDAB GammaRay compiled for this Qt version with this compiler, etc. So the matching KDAB GammaRay should be offered as part of the Qt binary downloads. It's so important, a tool. Okay. Information about it can be seen in the README, and it also has a website, kdab.com/gammaray, with more screenshots. Geometry tab. I did not see the geometry tab yet. And additionally, KDAB GammaRay can be compiled using the dependency of what's the name of the thing? Let's see. In the CMake lists file. State machine. KDSM enable state machine UI. So this is a library also from KDAB State Machine Editor. If you compile first the KDAB State Machine Editor and then KDAB GammaRay, GammaRay will have an additional tab, main tab, which is this one, which is called State Machines. I didn't have any use for it yet, so that's why I stopped building KDAB GammaRay with support for state machines. Okay, so KDAB GammaRay is really hard for the KDAB team to provide it as a binary package because it needs to be compiled with the exact same Qt version and compiler as the Qt version that you're using in order to run graphical user interface applications. Let's see how you can install and use KDAB GammaRay. The KD community has this wiki page, community.kd.org/guidelines and how-to/GammaRay. In here we say that the version should be exact same of Qt. So you'll need to, if you want to inspect a graphical user interface application that's installed using binary packages from your Linux operating system. So I'm on Ubuntu 24.04. If I want to inspect the kcalc that comes from the packages from the official repositories of Ubuntu, which is this thing. Install. If I would to install kcalc, then kcalc will depend on a Qt framework, so that will also be installed. And I can also install the GammaRay. So with this one command line, I'm going to install both Qt 5 and kcalc from KD Plasma 5 and GammaRay for Qt 5. So all three using the exact same version of Qt. And that allows me to start a kcalc that's from Ubuntu deb packages. We can confirm that. In components, it will say Qt version 5. And we can also connect to it using GammaRay. And now KDAB GammaRay can connect to way more applications because most Qt applications running on my machine come from the packages from my Linux operating system. So I can connect to this kcalc. There's also this Qt 3D inspector, so an additional top-level tab when you have more dependencies installed, so more Qt packages installed and that library from KDAB for state machines. Okay. If you're going to build an application, a Qt GUI application using the Qt from your Linux operating system, then again you should install both Qt, the development packages, and KDAB GammaRay using your Linux operating system binary packages. Then you're going to compile your GUI application using that version of Qt. Then KDAB GammaRay will be able to connect to your GUI application. And that's, for instance, if you're using KD's build framework, kdesrc-build. You're, for instance, on an Arch Linux operating system. You have installed the latest release version of Qt 6 from Arch binary packages. You can install KDAB GammaRay from there also. And then using kdesrc-build, you're going to build KD Git repositories such as kcalc, calc with 2Ks, using kdesrc-build. And then you will be able to use KDAB GammaRay in order to connect to those applications. And then there's the third possibility where you have installed Qt using the Qt online installer. So this thing. For instance, like this, you're installing the Qt current version from Git master. So you don't want WebAssembly, Android, Quick 3D sources, 3D debug information, but you want all of the rest. So go next. This will install the Qt from master branch on your machine, or you install Qt again from Git repositories, maybe from the master branch, maybe from the 6.7 branch, maybe from the 6.6 branch, but using the KD build framework, kdesrc-build, which is what I did on my computer. So let's see how that thing looks like. So under tilde/kd/src, I have the Qt Git repositories. So this is Qt base. We're on branch 6.7. We have all of the Git commits in here. We're using the Qt mirror Git repositories that exist on the KD infrastructure, https://invent.kd.org/qt/qt. Other Qt modules, Qt 6 compatibility with Qt 5, charts, QML, image codecs, keychain secrets, multimedia for audio output playback, shader tools for GPU, speech for TTS, text to speech, SVG for resizable graphics, Wayland, the web things, starting with Web Engine, which is a Google Chromium somewhere in here, this thing, and other Google projects such as GN and Ninja, and V8, this guy, the JavaScript engine from Google. Okay, so all of these I have built using kdesrc-build, and the output has been put into this directory by Ninja install, so tilde/kd/usr lib under here somewhere. I don't know where, but somewhere in here. So in tilde/kd/usr/lib libqt something. Libqt 6. Some of them are with uppercase Q, some of them are with lowercase q, which is a bug. Okay, so I have built Qt 6.7 using kdesrc-build. I am building KD Git repositories using kdesrc-build, which means that in order to have GammaRay of the same version as Qt 6.7, I'm going to need to build KDAB GammaRay using kdesrc-build, which I'm doing it using such a recipe in sysadmin repo metadata. I have edited the file module definition / custom -libs -qt 6-libs.ksp. At the end of the module set custom Qt 6 libs, I have added GammaRay. And at the end of the file, I have added options, GammaRay and options, and inside just repository, and then the path to the KDAB GammaRay Git project in GitHub. So this thing. This thing, not this thing. Counterintuitive, but that's the way it is. Okay, and then I have built kdesrc-build. The command line is kdesrc-build, and then GammaRay all lowercase. This has installed KDAB GammaRay in ~kd/usr/bin. This thing. Okay. In order to run the application that I have built using kdesrc-build, I am probably running such a command line, but kdesrc-build --run does not know how to run GammaRay because GammaRay is not using ECM extra CMake modules. So there's no file ~kd/build/gammaray/prefix.sh, but all of the files prefix.sh from all of the ~kd/build directories have the exact same content. So you can go source and then a random prefix.sh file, such as the one from the KD framework 6 kconfig ~kd/build/kconfig prefix.sh, and then the name of the executable file, which is GammaRay, because this will put in the path ~kd/usr/bin, among other things. Let's actually see what this thing does. Okay, so at the start of the path environment variable, puts ~kd/usr/bin, and then it does not need to set LD library path because the executables have inside them the full path hard-coded to the directories where the SO shared objects, dynamic loading libraries files are. But we need to set other environment variables for things such as Qt extra things, so Qt plugins, and QML themes and QML modules. And this is for the additional data and configurations. Okay, so first you're starting the application that you want to connect to, such as KCalc. Then you start GammaRay. In GammaRay, you will see a list of processes. GammaRay cannot probably inject into all of those, so be very careful. If you have multiple KCalc processes, close all of them and then open just one, such that you can select the KCalc process correctly. On Ubuntu family of Linux operating systems, the first time that you try to connect using GammaRay to an application, you might encounter such an error. So it's a message box with a title launcher error, and inside it says that inside of /proc/sys/kernel/yama/ptrace scope, processes that are not parent of kcalc, such as GammaRay, cannot connect using GDB, the GNU GCC compiler collection, GNU tool chain debugger to it. And that's a problem. You will want to disable this ptrace from processes which are not parent of the current process protection by following this wiki page. This is where it is documented. It sends you to these URLs. Okay, so what you need to do is to edit one file and replace a 1 with a 0. Then you need to reboot the computer. Okay, so that is it. This is how to install correctly KDAB GammaRay such that you can connect to a GUI application that uses Qt. In our case, this is mostly for improving and visualizing and debugging KD applications that I build from Git using kdesrc-build. Then the fact that you can connect to QML applications or to Qt Quick applications or to Qt widgets applications. The fact that you should start from the top level KDAB GammaRay widgets for Qt widgets applications and from the top level tab quick scenes for QML applications. And then you have in there a tree view of all of the controls that are visible on or that exist on the graphical user interface application. You have a list of all of the Qt objects or instances of Qt style classes that exist inside of the application. You have the list of all of the properties that exist on all of the objects. So Qt style properties on Qt style objects. You can at least read the value of most of the properties. You can set the value of some properties. I know, like 5% of the properties are settable from inside KDAB GammaRay. And in there you can see issues related to painting, related to wrong properties, styling issues, many types of graphical user interface glitches, buttons which are disabled when they should not. So all sorts of issues that you can both reproduce each time and you can also show them in the graphical user interface. You can point at them with the mouse. These things can be inspected and sometimes directly fixed using KDAB GammaRay. So maybe some of the issues you can actually fix in KDAB GammaRay by setting some properties. And then once you confirm that the bug has been fixed by just editing some properties, you can make source code changes such that you, in certain cases, set those properties programmatically. Thank you.